Welcome everyone. So this is the second part of the lecture 1, which is geometric dimensioning and tolerance, or the short form is called GD&T. So one of the basic elements in the engineering drawing is dimensioning. So let's see what is dimensioning. So dimensioning is a process where we want to specify the part information, for example, the size, the circularity, or the dimension of the object, by using the lines, numbers, symbol, and also notes. Here are some dimensioning components that you have to know before you start the engineering drawing. So here are the first one, what we call as extension line. So extension line is the line that indicate the location on the object features that are dimensioned. So for example, the black line that's shown in the picture on the right is showing the extension line. The second one is dimensions line, which is indicated with the arrowhead. So this one is indicating the direction and the extent of the dimension, and it will be inscribed in the dimension numbers. Okay, so here is the example of the dimensions lines. The third one is the dimension numbers or the dimension figures. So here we are going to write the numbers of the dimension using this format. Next is the leader line, which is the line that indicate the details of the feature with local notes. So let's see, this is the line with the arrow, and then we also will have the notes, which is the local or general notes that we want to indicate for the object that we want to dimension. For example, the diameter or the radius. So this is considered as the notes. So that's the 5 element of component of the dimensioning, which are the extension line, dimension numbers, leaders line, and also notes. Let's go into the dimensioning and their recommended practice. So here is some basic on how you want to perform the dimensioning. Okay, the first one, the picture in A showing a good practice for the dimensioning. If you can see, there is no intersection between the lines of dimensions. Okay, so if you can see here, this dimension and this one is not interacting to each other. Okay, so it is separated, and then if you are not able to prevent from intersection, there are not supposed to be any gaps to show the discontinuity of the line that you want to show here. Okay, so this is the good practice for the dimensioning. So let's see the B one. So if you can compare to the A part, this one, there are a lot of intersection between the lines. So this is not a good practice because it can create confusion. So that's why it is a no. Okay, so the third one is it is quite the same with the correct one, but the difference is only this one. There are gap here, so that it is not showing the correct the correct location for the dimensioning. So that's why it is a no. And the last one, the D one, the dimensioning error is located inside the object. So it will create confusion, and also there is no numbering or anything to show the dimension. So this is not correct because it will create the confusion with the visible line, the hidden and also the center line inside here. So now let us go to the extension line. So for extension line, you want to always leave a visible gap around 1 mm from a view of center lines before start drawing a line. So if you can see in the picture below, so these are the example of the visible gap between the lines. Okay, so before you start with the extension line. Okay, the second practice that you want to do is to extend the line beyond the last dimension line is around 2 to 3 mm, like the one shown here. Okay, so this one to indicate to show a good practice of the extension line. Now, what is the one that is not in a group practice? So for example, the first one, the distance between the line, the dimensions, the extension line to the to the dimension part is too far away. Okay, so the second one, let's see here, there is no gap, so it will create the confusion between the center line and also the extension line. The third one, there is no extra spaces for this one. So, and the fourth one, this one is because there is no connection to where the dimension is going to be. Okay, so that's why it is not a good practice. So another practice for the extension line is do not break the extension line as they cross any line types. For example, the visible line, hidden line, or center line. So let's see the good practice for this one. If you can see here, this is the extension line. So we don't show a cut inside here, so it's supposed to be showing the line to the part that we want to dimension, so you don't have to show a break. Okay, so a gap, a little bit of gap is okay, but no, not a break. So this is showing the wrong practice or the poor practice for the extension line. If you can see here, there is a break over here, so you want to show the gaps, but you don't want to show the break of the line. So for example, this one also and this one also, you want to show the correct location where you want to draw the you want to show the dimension. So now let's see the dimension line. So for the dimension line, it should be appropriately spaced apart from each other and the view. Okay, so the good on the left, it is showing the good practice where if you can see there are certain space between the part and also the dimension line. So it is supposed to be at least 2 times of a font size. Okay, so let's say this is the font size, so it double the 1 or 2 time of the font size. Okay, and if it is a double dimensioning, it's supposed to be at least 1 time of a font size. Okay, so this one is 1 dimension, so there's a space like one dimensioning over here, one size of the numbering, and then you start the second dimensioning in here. So for the poor practice, on the left, on the top part, you can see the space between the dimension and also the the part that we want to dimension is too close. Okay, and in between here also they are too close, so this is not, it can create confusion, especially if the drawing is very complicated. Okay, so the bottom part is because it is too far away, so then it can also create confusion because you might have certain things labeled also inside here due to this far distance. So here is the general guideline on how you want to put the dimension number. So the height of the number is suggested to be 2.5 to 3 mm, and this one is placed at about 1 mm above at a middle or the dimension line. For this one is for the ISO dimensioning. If you can see here, this is the numbering. Okay, so the number is placed like 1 mm above the dimensioning line. Okay, so here is also the good practice for the dimensioning. So as for this one, this number is too far away from the line. This one is intersect the line, and this one is not on the center. However, if you are involving the multiple dimensioning, for example like this one, The first one, it is suggested to be in the middle, but for this one, it is not supposed to be in the same line for the numbering. Okay, so it is suggested, it is staggered. Okay, like the location is over here. As for this one, the distance is different, so it's okay, it's placed in the center. But in the actual one, if let's say the picture is in the same area, the numbering not supposed to be in one line, so that it can create confusion. Now let us go to the next part, which is the surface finish and tolerance. So when you go into the industry, you're going to look into this drawing a lot. Okay, so each of the symbol and the marks inside this drawing represent certain tolerance or certain characteristic of the product that being created. So for example, this one, okay, so these are the symbol for the tolerance. Now let us see how it is represented in the drawing. So the first thing that you have to know is the feature control frame. So in this feature control frame, it will represent on what are the components that you have to know. So the first one is the leader arrow. This arrow will show you where is the location of the tolerance is supposed to be. The second one is the geometric characteristic symbol. So let's say for this one is the circularity or perpendicularity or something like that. So that you have to follow this, you have to read on this one. So this one I'm going to introduce to you after this. Okay, and then we also have the diameter symbol. If it is involving the diameter, then you are going to see the diameter symbol, and this is the stated tolerance that you have to read. Let's say this diameter must be within 0.014 in tolerance. And then there are also certain part that we call as modifier for the state tolerance. So this one is for additional tolerance reading inside the drawing. And then the three part over here is representing the datum. Okay, so they have primary datum, secondary datum, and tertiary datum. Okay, so let's see the details of this part. Now let us see the summary of the symbol. If you can see in this table, this symbol, the first symbol is showing the flatness. The second one is straightness. Third one is cylindricality, and the fourth one is the circularity, roundness. So this is grouped together, and the tolerance type is it's called a form tolerance. So there is no relationship between the features. So this one is control form for the shape of the object that we're going to create. So the second one is orientation form, orientation tolerance. So this one is indicating the perpendicularity, parallelism, okay, and the third one is angularity. Okay, so this one is controlling the orientation, let's say the tilt of the surface or axis. Okay, and then for the third one is the third group will be the location tolerance. So this one is in terms of positioning, profile of the surface, and profile of a line. Okay, so and the fourth one is the run out tolerance, is indicating the total run out or the circular run out. And the last one is the concentricity and also symmetry of the part. So this one is under the location tolerance. Now let us see the first example, which is the perpendicularity example. Okay, so if you can see the symbol in the first part here is showing the perpendicularity. This is how much is the tolerance, and this is the datum. Okay, so if you can see here, this is already defined. The datum is at A here. Okay, so how do you want to read this drawing? Okay, how do you want to read the tolerance? So it is stated that this is the datum. So the datum is already specified. So this is the possible, because it is positioned over here. Okay, so meaning that they mean this surface. Okay, so when it is like this, how do we want to read this? Is the surface must be within the specified tolerance size that must lie between two parallel plane, which is around, this one is only allow around 0.12 white tolerance zone. Okay, and then apart which are perpendicular to the datum plane A. Okay, so meaning that this surface must be perpendicular to the datum A. Okay, so that's why the symbol is like this. So now let us go to the next example. So if you can see in the picture, it shows this symbol and then the tolerance number. Okay, so if they say that this is the surface that they want to show the flatness, okay, so it means that this surface must be within the specified tolerance, where the tolerance zone is around 0.25 only is allowed. Okay, so then the surface not supposed to be, let's say the waviness of the surface cannot be more than 0.25 of white tolerance zone. Okay, so the next one is the roundness. So if it is, you see the symbol of this one, it is mean it is a roundness, and this is the number for the tolerance. So it means that each of the circular element of the surface in any plane perpendicular to a common axis must be within the specified tolerance of size and must lie between two concentric circles. So it is in between the concentric circle here. It's not supposed to be more than 0.25 difference in terms of the difference. Okay, so meaning that the circle must be within that tolerance zone. And the next one is the cylindricity. Okay, so sorry. Okay, so this part, if you can see the symbol here, and this is the number on what are the tolerance. So if you can see here, for the cylindricity, the cylindrical surface must be within specified tolerance of size, and it must lie between two concentric cylinder. Okay, so if you can see from the side, they are supposed to be within the range of 0.25 difference. Okay, so the circle cannot go more than this concentric area. Okay, so the radius must be 0.25 larger than the other. Okay, one having a radius 0.25 larger than the other. Okay, now let us see another two example, which is the angularity and the parallelism. Okay, so for the angularity, if you can see from the top one, it's already given to you that this is the symbol for the angularity, meaning that the part has the angular. This is the tolerance that you have to know. This is the datum, and then it is already defined the datum A to be this one, and this is the angle that you're supposed to satisfy. Okay, so here is the meaning on what are the things that been written on the top. Okay, so the surface must be within the specified tolerance of size and must lie between two parallel plane 0.4 apart. So this is the tolerance that stated inside here, and which is inclined at 30 degree to the datum plane A. So this is the angle that stated previously, and this is the datum A. So this stated inside here, and the surface within the specified tolerance of size of the angularity here is the tolerance 0.4. Okay, the next one is the parallelism. So if you can see, this is the symbol for parallel. This is the number for the tolerance. okay, and this is the datum. So here the datum A is already defined over here. So this one is read as the surface must be within the specified tolerance of size, must lie between two planes 0.2 apart which are parallel to the datum A. So this is how they define the meaning of the part shown in this picture. For the rest of the tolerance symbol, I've already put it inside the Google Classroom. It is going to be your reading assignment. You can look into the what we call the material that I've already attached, so that you will understand more on the tolerance symbols. That's the end for our lecture today. Please don't forget to fill in the attendance in the attendance form attached in the Google Classroom. Okay. Thank you for listening. Assalamualaikum.